Picture this. A patient walks into the emergency room with chest pain and sky-high blood pressure. The doctor reaches for a medication that can literally save this person's life within minutes. What kind of drug has this incredible power? The answer is calcium channel blockers. These medications are absolute game changers in cardiovascular medicine. They can stop a heart attack in its tracks, bring down dangerous blood pressure levels, and even prevent migraines. But here's the thing most students struggle with. How exactly do these drugs work at the cellular level? And why are there different types that seem to do completely different things? Today we're going to break down everything you need to know about calcium channel blockers. Let me start with a story that perfectly illustrates why these drugs are so important. Sarah is a 55-year-old teacher who started experiencing severe chest pain during her morning class. Her blood pressure was dangerously high at 180/110. The paramedics gave her a small tablet under her tongue. Within 10 minutes, her chest pain started to fade and her blood pressure began dropping. That little tablet contained a calcium channel blocker called nifedipine. But how did such a small pill create such a dramatic effect? To understand this, we need to start with the basics. What exactly are calcium channel blockers? Calcium channel blockers, or CCBs as we often call them, are medications that interfere with calcium movement in our cells. Now you might be thinking, why would we want to mess with calcium? Calcium is not just important for strong bones and teeth. Inside our cells, calcium acts like a key that starts many important processes. When calcium enters a muscle cell, it triggers that muscle to contract. This happens in the smooth muscles around our blood vessels. It also happens in our heart muscle. So when we block calcium from entering these cells, we can control how these muscles behave. Calcium channel blockers primarily work on smooth muscles, especially those found in blood vessel walls. They also affect our heart's activity by decreasing heart rate, reducing the force of contractions, and slowing down electrical conduction. Now here's where it gets interesting. Not all calcium channel blockers are created equal. There are actually 3 main classes, and each one has slightly different effects. The first class is called DHPs, which stands for dihydropyridines. The most famous drug in this group is nifedipine. Other examples include amlodipine and felodipine. These drugs are superstars when it comes to relaxing blood vessels. The second class has just one main drug, verapamil. This drug affects both blood vessels and the heart, but it has particularly strong effects on heart rhythm. The third class also has one main player, diltiazem. This one sits somewhere in between the other 2 classes. It affects blood vessels like the DHPs, but also has significant effects on the heart, like verapamil. Now let's dive deep into how these medications actually work at the cellular level. This is where the magic happens, and understanding this will make everything else click into place. Our cells have special doorways called voltage-sensitive calcium channels. Think of these like automatic doors at a grocery store. When the right signal comes along, these doors open and calcium rushes into the cell. In blood vessels, smooth muscle cells, when calcium enters, it binds to special proteins. This binding triggers a cascade of events that causes the muscle to contract. When the smooth muscle around a blood vessel contracts, the vessel gets narrower. This is called vasoconstriction, and it increases blood pressure.